From section 6.3, let's take the problem x squared plus 7x plus 12 and use both a visual approach and an algebraic approach to solve this problem. For the visual approach, we'll go to the National Library of Virtual Manipulatives. We'll start the problem exactly how it's written, that is, an x squared plus 7x's plus 12 units. From this unorganized group of figures, we will now attempt to create a perfect rectangle so as to use the area model for multiplication. We will attempt to take the lessons learned from Chapter 5 and work backwards towards a solution. If you recall, the nomenclature of multiplication problem is a factor times a factor equals a product. We have a product of x squared plus 7x plus 12. And we now would like to see what factors are used to create this product. Our first step will be to place the x squared in the corner and then attempt to align the x's and units so that we can create a perfect rectangle. This may take some trial and error on your part. If you start with creating a perfect square and then evaluate what is left over, your decisions will be limited. You will then continue the process until you are left with a decision on what to do with the remaining pieces. At this point, we can see that we have 1 x and 3 units left. We can place the x on either the right or the top, then place the remaining units above or next to the x. Let's examine the rectangle. What is the length and what is the width? We notice that x squared has an x on each side of it, and the width of each x is a single unit. So one side of the rectangle is x plus 3 units, and the other side of the rectangle is x plus 4 units, which then produces our answer of x plus 3 times x plus 4. This virtual manipulative only works when both signs in the problem are positive. If one of the signs in your problem are negative, we will then need to use an algebraic approach. Let's take that same problem and we will need to factor just the constant number. Remember, the constant is a value in our polynomial without variables attached. Now let's factor the positive 12 with all the possible factors. We'll start with 12 times 1, then 6 times 2, and 4 times 3. You might think we are done, but when there is a negative present, we will also have to continue. So let's continue factoring with 3 times 4, 2 times 6, and 1 times 12. Let's examine our factor constant and figure out which factors add up to the coefficient of the middle term. Let's recall that the coefficient is a number in front of the variable, or the constant number being multiplied to the variable. We can see that there are two answers, the 4 times 3 and the 3 times 4. Both answers are acceptable, and you could use either answer. We covered factoring by grouping in 6.1, and we'll use it to factor this problem as well. What we'll do first is use the 4 times 3 and replace the 7x with 4x plus 3x. From our new equivalent expression of x squared plus 4x plus 3x plus 12, we will group the x squared and 4x as well as group the 3x and 12. Looking at the x squared plus 4x, we can see a common factor of x, leaving us with x times x plus 4. Looking at the 3x plus 12, we can see that it has a common factor of 3, leaving us with 3 times x plus 4. Now looking at our equivalent expression of x times x plus 4 plus 3 times x plus 4, we should notice that each pair shares a common factor of x plus 4. Factoring this out, we are left with x plus 4 times x plus 3, the same answer we found using the manipulative. Let's now look at a new problem with one subtraction sign instead of two plus signs. T squared minus 11t plus 28. Let us first take a look at the factors of positive 28, which would be positive 28 and 1, positive 14 and 2, positive 7 and 4. Switching them around, we would have positive 4 and 7, positive 2 and 14, and positive 1 and 28. We also need to evaluate all the negative factors of 28, like negative 28 and negative 1, negative 14 and negative 2, negative 7 and negative 4, negative 4 and negative 7, negative 2 and negative 14, and negative 1 and negative 28. Which set of all these factors, when added together, give us the coefficient of negative 11? That would be both negative 7 and negative 4 and negative 4 and negative 7. We now rewrite an equivalent expression of t squared minus 7t minus 4t plus 28. Now let's group together t squared minus 7t. Now a minus 4t is the same as a plus a negative 4t. We can then group the negative 4t and the positive 28 together. From the t squared minus 7t, we can factor out a t, giving us t times t minus 7 Next, we should factor out a negative 4. This way, what will remain is a t minus 7. Since we have a t minus 7 in both terms, we can factor t minus 7 out, leaving us with a t minus 4. Our final answer is then t minus 7 times t minus 4.